Hey class. So this video is dedicated to exponents. Now exponents are a major topic in mathematics, science, any real technical subject. You need exponents when you're calculating things that are microscopic. So like really tall or tiny organisms. Or calculating things that are huge. So like the distance from, let's say, the Earth to the moon. Okay, so this video is dedicated to different types of exponents and different types of calculations. Overall, in this video, you're going to see 6 different ways or properties and rules for exponents. Okay, so I'm going to give you the first one. Alright, so the first one we're going to be talking about is product of powers. And you see the rules over here? I'm going to give you one example per property. Okay, so your example for a product of powers is going to be this. We're going to have 2 to the third exponent times 2 to the fourth exponent. Okay, well, in a product of powers, what you're supposed to do is you have a product, so a product means you're going to multiply. Okay, so we're multiplying right here. Now, when we have powers, we're not quite sure what we have to do there. Okay, well, let's distinguish what these two things mean. 2 to the third exponent, what that means is just, well, 2 times 2 times 2. Okay, simple enough. And what does 2 to the fourth mean? Well, in the same sense, it means 2 times 2 times 2 times 2. So 4 times. Okay. Overall, we have a product. We're multiplying a bunch of these 2's. How many 2's do we have? Well, we have 7. So this is equal to 2 to the 7th power. Now there's an easier way to arrive from this to our answer. Now what could I have done 2, 3, and 4 to arrive at 7? Well, you're just going to add. So when I have this problem, I'm just going to rewrite it. You're just going to add the exponents. When you multiply bases, you add their exponents. It's as simple as that. So we're going to write 2 to the third plus 4. So 3 plus 4 is in our exponent, and that just gives us 2 to the 7th. And that's our answer. So remember, when you see something like this where they have common bases, you just add their exponents. And that's what gives you your answer for product of powers. Alright, next one that we have, next property, is a power of powers, where you have a base raised to an exponent, but that entire thing is raised to another power. What do we do there? Alright, so I'm going to give you an example for that. Okay, so let's put this off to the side. And our example is going to be b to the fourth. I'm going to put that in parentheses, and we're going to raise that to the 5th power. Okay, what is that equal to? Well, let's just take, I'm just going to cover b to the 4th. Anything to the 5th exponent, what does that mean? That means you're going to multiply that thing by itself 5 times. Okay, so I'm going to write b to the 4th 5 times. Alright, so b to the 4th, b to the 4th, b to the 4th, and b to the 4th, and one more, b to the 4th. Okay, well, right now we're multiplying a bunch of things. They have the same base, and well, for this, they have the same exponent. We did this. We did this in the last one. When you multiply bases, you add their exponents. Well, let's add them. So I'm going to put b, we're going to add 4 plus 4 plus 4 5 times. Okay, well, 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, I believe. So we have b to the 20th. That's our answer. Alright, but let's look at this. Instead of doing all of that work, there's an easier way to get the answer. Let's look at 4 and 5. What could I have done to 4 and 5 to get 20? Well, I could have just multiplied them. So, when I write b to the 4th raised to the 5th power, what I like to do is I like to circle them, and I like to put an x in between. So I know that I'm multiplying. So this is going to be b to the 20th power. That's what we get. Easy as that. So this is for power of powers. Okay, next exponential property that we have is a power of a product. Okay, product meaning that I'm multiplying two things, so I'm multiplying A and B, and I'm raising that product to a power. Okay, now look over here, that gives you a hint of what we're going to be doing. Okay, example. I'm going to give you 3x raised to the 6th power. Alright, so we have a product, 3x. When a number is next to a letter, every single time you see it, they're multiplied. So we know that there's multiplication involved here. Okay, what we're going to do is I'm just going to cover up 3x. It's raised to the 6th power. What does that mean? That just means I'm going to write 3x 6 times. Alright, so I'm going to do this again. So let's go fast through this. And I'm getting tired, so I'm just going to write it one more time. Alright, so overall, we have 6 of these. Okay, now what you're supposed to do is when you have a product, right over here, so I'm going to write the same thing. You apply this exponent to everything that's being multiplied. So I'm going to put this exponent to 6 to x and also 6 to 3. Okay, meaning that they both share this x, right? Okay, so we're going to have 3 to the 6th power times x to the 6th power. That's what you get. That's it. Okay, now I'm going to give you a more difficult problem. This is going to incorporate a power of products, or sorry, power of product, and also another one. It's going to also incorporate a power of a power. Okay, this sounds complicated. Don't worry. What if I wrote the same exact thing? So 3x, but on the x I'm going to put squared. I'm also going to raise it to the 6th power. Well, what we do is we still apply that exponent to everything separately. Okay, so we're still going to have 3 to the 6th power times. Now this part right here, okay, this where incorporates the power of powers. Because now that I have a power raised to another exponent, what you do is multiply. So this will become x to the, it's not going to be 6, you're going to multiply 2 times 6, which is 12. Alright, so that's the only difference, is when you have an exponent already there, you multiply them. You smash them together, what we got is 12. Alright. Okay, next property that we have is negative exponents. Normally you don't see negative exponents. When you ever see a negative exponent, you want to get rid of it. Okay, we need to make it a positive. If we want to calculate something with it, manipulate it, anything, you want it to make sure that it's positive. Okay, well, let's look at this. Okay, so I'm going to write, our example for this is going to be m raised to the negative 4th power. Now when you have a negative exponent, a key word that we need to use is called reciprocal. Okay. Now, normally use reciprocals when you have fractions. Okay, so I'm going to write a fraction. I'm just going to put a over b. This is separate from this. And a reciprocal, all you're doing is you're taking that top number of the fraction, so our numerator, and the bottom, which is the denominator, and you're switching them. Okay, well, a was on top, it's going to go on the bottom, b was on the bottom, now it's going to go on top. So the reciprocal of a over b becomes b over a. Alright, so let's use that to this. Well, m raised to the negative 4th, we need to make this into a fraction. Okay, I don't see one. Whenever you have something that's not a fraction, an integer, a decimal, whatever, you make it into a fraction by putting it over 1. Okay, so that's the key thing. Now we can use the reciprocal. Alright, so we're going to switch the top and the bottom. So instead of 1 being on the bottom, it's now going to go on the top. Instead of m to negative 4th on the top, it's going to go on the bottom. But a magical thing happens. When you do flip this, it becomes m. The magical part is where the negative 4 becomes a positive 4. So, that's that. So we're going to have 1 over m raised to the 4th power. Okay. Let me give you one more example for that. Let's say if I gave you 6 raised to the negative second power. Well, same idea happens here. Just put it over 1. Okay, make it into a fraction. And what we do, flip them. Instead of 1 being on top, or instead of 1 being on the bottom, it goes on the top. Instead of 6 to the negative second power on the top, it goes on the bottom. So we're going to have 6, but you change the exponent. Negative becomes positive. That's it. Next property that we have is a quotient of powers, meaning that I have two things, they're written as a fraction, and we need to understand what we do in a fraction with their powers. Okay, well, if you look over here, the bases must be the same, but whatever we have the powers, we're going to do something. Okay, we're going to keep that in mind. Alright, so this quotient of powers. Our example for this is we're going to have y to the 6th power and y to the 2nd power. Well, let's just write what they mean before we get into the actual properties. Well, what does y mean? It just means y times itself 6 times. Okay, 1, 2, 3, 4, 5, 6. Okay, and on the bottom we have y squared. So, y times y. Okay. Now, key thing with fractions is if you have something on the top and the bottom that are the same, you can get rid of it. You can simplify this. Well, let's cross out how many y's we have that are in common. We have one y over here and another y over there. Okay, so how many are we left with? Well, we're left with 4 y's, or just y to the 4th power. Okay, so having said that, what could I have done to the exponents? What could I have done to 6 and 2 to get 4? What you do, I'm going to rewrite it. So y to the 6th power over y to the 2nd. The key thing, so when you are dividing, you subtract their exponents. Okay, so I'm just going to write y. We rewrite this. I'm going to put 6 minus 2. So 6 minus 2. Just simplifying that, you get the same answer. Y to the 4th. Nothing happened with the base. You just subtract the exponents. Alright. Alright, last property that we have for exponents is a power of a quotient. What this means is if you have a fraction and that entire fraction is raised to a power, you put that power to the numerator and the denominator separately. Not too much arithmetic or computation involved. Let's just go through a quick example. I'm going to write 3 over 8. So that's our fraction. That's our quotients. Fractions and quotients, they're common. They're in tandem. We're going to raise this to the 2nd power. Okay, well, what that means is that everything, the numerator and the denominator, both get that exponent. So I'm going to put that 2 to the 3 and the 2 to the 8. Meaning that what we're going to get is going to be 3 squared over 8 squared. That's it. All you do is put the exponent to the base. Not too much computation there. Alright. So having used that last property, we're done. I'm tired. We're going to do more computation with this. Working with exponentials, it's an important thing. You need this for Algebra 2, you need this for calculus, you need this for... This is actually used for a lot of professions, a lot of sciences. But, hope you got a lot out of this video. Mr. V, signing out. Bye.